started another stream. We're doing the same thing. Let's full screen this. Alright, so we got this geometry, spatial geometry problem right here. We got this thing right here. If it's gonna be hard, I'm just gonna skip it because I'm focusing on the easier stuff. So basically, the base with a small line of the base is 2 centimeters. The longer one is 2. That times 2, so basically 4. And one angle is 60 degrees right there in that base rectangle. And if one is 60, then I guess the other one is also 60, and in total it gotta be what, 360? Yeah. And this means the other ones, to get 360, they gotta be 120. I guess like that. But isn't it like 90 degrees on all of them? And this kind of shape in the base, I gotta check it out. What's up with this 60 degrees? So I gotta understand the volume of this thing. Knowing that the diagonal of a big, so basically a big diagonal, the whole diagonal of this thing is gonna be drawn out here. It's not gonna be an issue. And that diagonal forms a 4-degree angle. Yeah, let's, I guess, watch it how it's done. Let's see how it is. So basically, first noting everything, the bottom base ABCD and the upper one A1 B1 C1 D1. 2 right there, 4 right there, so 60 is bad, so like I thought. So this means that the other one's also 60 as far as I know. But it's gonna calculate that, and this is the main diagonal. And our there is forming with a base 30 degrees right there. Basically gotta write down formula of the volume. And you have to understand what you have to find, like the height of this. He decided to draw the diagonal from a different perspective. 30 degree right there. Okay, so volume, that's the formula. Area of base times height, and area of base is just 2 times 4 should be that. This one's a sine, so yeah, I'm gonna skip it. You know, I just saw the trigonometry and skipped it. That's not what I want to solve right now. This is higher difficulty. So let's see if there's something else. If not, we're gonna just find another video. This is also trigonometry, and this next one should be also with parameter, which I don't need. So could find another one real quick and be back. So pause screen. I've just covered this video. We have two webcams, this guy and me. That's no problem. So we have a problem. It should be without sign and stuff like that. We have this triangle, and this triangle has the lengths that are not the hypotenuses, basically the same, and the middle kind of line from the hypotenuses is 2 square root of 2. Find the middle line of one of our lengths, whatever, I don't know this terminology in English. Basically 45, 45 for some reason. Why, you ask yourself? Because 90 degree right there, the same length, so it's 45, 45. Because it gotta be 180 in total. That's basically the the middle length from the hypotenuse, 2 square root of 2. And I guess here we use some formula. So we gotta understand a length like this, I guess. So I'll do that with basically Pythagorean stuff, right? So that's BAD triangle. Go that right there, and we gotta understand first what is BA. So BC is 2AM. So yeah, we can understand that this is the length of BC based on that. And now what? BC is going to be AC times square root of 2. Here's some formula and stuff, so it's kind of hard and stuff, so I'm going to skip this one. This one's also with derivatives and stuff. I'm not going to go over this. Should be having stuff like this. This is what I'm talking about. Probability problem. And we have essentially, we're taking a random number that has 4 digits. 4 digits, right? Find probability that this number contains only, I think I did something like this, so I'm gonna skip this over. Yeah, you can see how basically it's solved. It's not that hard. Let's skip this one. I already watched this. When I'll be done, or watch every single video I can find, I'm gonna solve from the problem book using the setup, like my setup, with a phone and the S-Pen. Okay, so we got this problem. This one's pretty hard with a circle. I don't like it. I'll just move on. This equation is also pretty hard. And that's it. We gotta find another video. I saw this one. I think it should be pretty good. Let's see it. All the way to 5. It's gonna start from 5, I guess. This equation stuff is also pretty hard. I mean, I guess I could try it. Basically, with stuff under the square root, you gotta put it bigger or equal to 0. You get that. And so you have the square root. So what I want to do is get everything to the second power, and then you solve that quadratic stuff, and yeah, that should be it. I mean, perhaps this example is not that difficult. You do the intervals, and basically you get exactly what you need. So first DVA, that's DVA, and this guy actually got like some other approach. Watch, no DVA is necessary here. Got this approach. Well, I guess. So I took the DVA wrong stuff. I thought it's the stuff under the square root. Anyway, so basically you crack open this parenthesis and you have this. Exactly this. Then you pop the TVA once again. Then you have that, you move it over. Plus 4x. Here I guess you gotta take the common factor out, which is gonna be x. So got out, took the common factor out. So x is either 0 or x is 4. Because minus x is going to be minus 4, just flip the signs, and basically x got to be bigger or equal to 1 divided by 2, which is 4 in this case, so it got to be just 4 of a solution. But as it is an equation, you got to do the interval, so you place this there, and you have from 0 till 4. Yes, from 0 till 4, minus plus minus, like that. And you gotta take the positive values, or actually the negative values. Why the negative? Because it's smaller, I guess. So we have minus right there, because if we put, for example, 1 in that, in the minus x to second power plus 4x, if we put a 1 right there, we get minus 1 plus 4, which is positive, so I guess stuff like that, and then you got a positive. Then 4 plus infinite, it's smaller or equal, so you put the parentheses that is with like rectangular edges, and you take the result that's bigger than 1 divided by 2, and you get this solution. Yeah, this one's trickier. Okay, so we got this exercise with imaginary numbers, which is better, I guess. Alright, so to do this exercise with imaginary numbers, we have z, which is 2 minus 3i, and obviously at a second power is minus 1. Find the real values of p, knowing that z at a second power plus pz is real number. So what it means is real number? Well, it means that the imaginary part of z is 0. That's what it means. So you just plug in the z right there, equal the real imaginary part with 0. I mean, just work with the real part, stuff like that, and you're gonna get values of p from there. That should be it. So you just plug in the z right now, second power, plus p, and then plug in that z, Now we just use the formula for 2 minus 3i second power. It's going to be 4 minus 2 times 2, which is going to be 4 times that's 3, 12. We got an I right there. And minus plus actually 9 I to the second power. And there we have 2p minus 3pi. Okay, now we just remove I to second power by switching the sign, and we got minus 9 plus 2p minus 3pi. This is what we have currently. And from here we just remove imaginary part, right? So minus 5 plus 2p. He has written everything so far. Okay, let's see how it goes from here. Yes, this equal in the real range, not imaginary. So the imaginary part, you took it out and put it equal of 0. But without the i's, and basically some explanation right there. And basically you have that minus 3p is equal of 12, so p is equal of minus 4. And you pop it in the response, and that's what you have right there. I'm gonna skip right on. Go to the fourth exercise on this list right here. You have that under the square root 100 minus lg2. lg is the log actually with a tan base. So what you do here, you pop the tan base so it's clear, and then the tan, the 100, you put it 10 power 2, right? So you're gonna just multiply 2 with a whole power, and then you're just gonna work from there. I'm gonna see how it is, use some properties, and it should be alright. You just take the expression out of our square root. I guess you can work like that. So what it did is he put the power below like that. I didn't quite know about this property. Whatever, you can use it. He's explaining it right now. And yeah, we're gonna work from there. Yes, if it's minus like that, so it's basically that divided, I guess. So you have 100 right there. I think you should put 10 to the power 2 on top, I don't know. Right there you have 10 to the power 2 times lg of 2, which is, like I said, log with base of 10. 100 right there, lg of 4, so I can actually just pop that, 10 lg 4, and that is 4, huh? How the hell that is 4, man? From where'd you get that? 10, if it was LOGs, oh yeah, so it just cancelled out because log base 10, so it's cancelling out of that 10 is 4, yeah. As the property right there. These videos are for non-nerds, so why did he skip that step? So we didn't forget about square root, that's gonna be 5. So that's his natural number. Now I guess it's gonna do exercise 1. So he's doing exercise 1. That's 1 divided by 2. He has written it down as 2 at power minus 1. That's acceptable. And basically we need to pop numbers, but this kind of exercise is not really present in current tests, so fuck this exercise. I'm just gonna skip on. Minus 1, 0 right there. So popped, oh my gosh, saw that shape. Okay, so back to exercise 7. I mean, what am I saying back? We didn't grasp this exercise yet. We have this diagonal, I mean not diagonal, it's actually, I don't know what the shape is called. Basically it's like a square that's to the side like that. And there's the smaller diagonal in this, which is 30. And the height is 24. Find perimeter. Obviously you gotta know perimeter of this stuff. Formula. Let's see how it is. I guess this one is a bit hard, but I really know. If it's just some Pythagorean theorem, I can handle that. So 24 right there, pop a height, which is m right there. So 9 degrees right there in the m. So we can understand what is the MD. But we're gonna see if we need that. Basically we need the perimeter right here. Pop the Pythagorean. So you have essentially this. So finding out what is MD is 18. He just explains how it's like that type of triangle, and if you multiply by 6, the same thing. So you just got it 18, 6 times smaller than 24. With some geek stuff, so I'm just gonna skip over that. You pop the x right there, x plus 18 right there, yx plus 18 because AD is the x plus 18, so AB is the same because this kind of shape. So what to do now? Well, I guess I don't know if you can get the perimeter right now. I think no. X minus 18, you pop right there. Well, I guess that's a way. I don't know why I did that. X minus 18, so x second power is going to be 24. That's Pythagorean again, guys, in the triangle A and B. Didn't write that down. Actually, he did write it down. So you have that. Pythagorean again. Working with x. So basically, once you know x, I guess we can calculate what the perimeter is. X second power, which is AB by hypotenuse, is equal to 24 second power plus that's AM to the second power. So then use the formula right there. I guess we need to use quadratic. I don't need that. I don't think we need to use quadratic here. 36x is going to be that because x second power cancels out. So x is going to be that divided by 46. So basically works with power, 6 power 2. That divided right there and that divided right there. I guess you can got a 16 right there. Yeah, 9 right there. How? Well, 24 divided by 6 is not 16. It's 24 minus 6. That's 18. Still doesn't work. So what I did there? How he has completed that? 24. I don't know, maybe it has a calculator or something like that. Or I can find out, let me see. How was that calculation possible so fast? I'm gonna see right here. Okay, got it now. I understand why it's like that. It's quite simple. It's I said 24 divided by 6 is not 16, but it's actually 4. Yes, and second power is 16, so that's essentially how it's done. That's 3 reverse second power is 9. So that's property, that's 25 right there, so AB is 25. So perimeter is 100 because that's times 4, so we got the 100 right there, so pop that. Goddamn hexagon, like, what? You gotta be kidding me. This one's too hard, man. Is this gonna be with sine? And it's not gonna be with sine, but you can see it's pretty hard. You gotta take stuff out, and it's not exactly nice. I'm just gonna skip it through. Let's see which ones now. So I don't know if I watched this before or no. Perhaps no. Essentially I have this. There are 10 numbers from 0 till 9, and a code is being formed of 3 digits that are all distinct. Find probability that the code contains 0 and 1. So in order to do that, I don't recall this, so yeah, I'm just gonna do this. So we gotta do the formula of favorable cases divided by all cases, and all cases, how we can understand that. We have have essentially 10 with exclamation mark, or do we have that? No, we don't have that. We have a 3-digit code. So first one can't start with 0 as it is a code, is not a number. So it's going to be 10 times 10 times 10, which is 10 to the power 3. That's all the cases. And now for the favorable ones, you just write down 3 circles like that. On the first circle, it can be 0. On the second one, 1. And on the third one, it can be any number other than 0 and 1. So basically the remaining 8 numbers. So it's going to be 8 on one row, but we have also other cases where the 0 is the last number and stuff like that. So that must be also taken into consideration. So we multiply by how many cases we have, and basically we get that we do the simplification, we get probability. So I'm just gonna see what's written here on this professional exam solved. So basically he proceeds to complete this with arrangements, which I guess makes sense because you just arrange this numbers, and it doesn't matter their position, which one's first, which one's second, because it's a code. So I guess my approach wasn't right. We gotta do the arrangements. So from 10 digits we form a 3-digit code, which makes sense. So we solve that. And in the favorable cases, I guess we'll have with the M, right? With the M, which is the favorable cases, and what that will be? That will be first one. You have 10 digits and you take 1. Second thing also kind of the same, and basically with arrangements we'll work that if we started like this. So I don't think my approach was right anyway. The arrangements it is. So we have 720 right there. Let's skip through. He did 8 times arrangements of 3 take 2. Well, yes, that makes sense, but I would take another approach here. He's done it way too short and it's not really clear. He popped the 8 because there are 8 different digits which can be on basically the code, and the A stuff he took from 3. Why from 3, bro? You basically take 0 and 1, which are 2, but why take 3? You have 0, 1, and what? Why does he take 2, man? I gotta understand this, man. I'll be back. Okay, got this one. So essentially you have 8, right? And the A32 because we got the code is free and you take 2, so 0 and 1, so that's why. That's why. Now just solve it. You have 2 right there. So it's going to be 2 times 3 divided by 2, which is 3. So that's going to be 24. So it's going to be 24 divided by 720. Obviously that can be simplified. Bro, it's 48. Why 48? You have what is wrong with this morons? It's not 48. Top you have 2 times 3 and bottom you have 2. So should be just 24. Anyway, fuck them. They're gonna probably correct themselves. Okay, so now my method is being shown, right? Okay, so I had it a bit wrong there. I said the total number of cases, basically 10 times 10 times 10, which is not right because you have 10 numbers, first one right, but it took 1, so now it's going to be 9 and stuff like that. So that's going to be 720. And now on the next stuff, x01, so it's going to be 3 exclamation mark because y 01, you have 01. So why 3 exclamation mark? You have 01. Doesn't really make sense. I have to take this into account also. Let me see real quick. Okay, so basically why it's free exclamation mark, it is because X is moving around on free positions, so that's why it's free exclamation mark. Fuck that logic, whatever. So that's gonna be 8 times 2 times 3. So basically just popped 1 divided by 15. Whatever, man. I'll move on from here. This one I'll skip, it's like limits and so on. Derivatives. So fuck this. This stuff, same stuff. This is for geeks. Skip this. Yeah, this one is also for geeks. Look how long it is, god damn it. Well, I'm gonna research a bit more. Another video, let's see. Yeah, I got this now. This one's a bit hard, I guess. Um, so maybe I should skip this, I don't know. Pop this to the left. Now what? We take the common factor square root of x below, so it's going to be 1 minus square root of x divided by square root of x. Now what? Well, now you just work with a part on top and so on. So that is that. So that is that. So that is that. Work with DVA, work with that. So we take the common interval, and you got this. Yes, that is about right. So basically you got this matrix, and you gotta find the complex number z for this matrix not being inversible, which is basically when this matrix is equal to 0. So you just solve this. Z is a plus bi. You know that out of second power is minus 1, and you basically work from here. It should be not an issue. IZ right there, that right there. So you just multiply diagonal and you do a minus. That's going to be equal to 0 because you know that this big A is all equal to 0 because not inversible. And so you have received this equal to 0. That is equal to that. And now what you do, that's a matter of solving it. So that's going to be divided by, and that's going to be divided by I. Here you have to solve, multiply by the changed up thing, I think minus 3, minus 6i, stuff like that, or just minus I, so basically what's below. And you multiply by that, and you will get essentially this. This is a method. I would adopt another method, but anyways, you could take that. So below you'll have minus 1, and with a minus it's going to be 1, so basically the thing on the bottom disappears. And there you have 3i plus 6 right there, and that's it. So he popped it like that, and that is z. 6 plus 3i, just switched it around, no issue. And now where are we heading? We're heading on to the next exercise. Find the media. So basically you have to plus these numbers and divide them by 2. Log 3, 18. How would you write down 18? Well, 18, you cannot put it at a power. Well, you can think about 9 times 2 and then 3 power of 2 times 2, but I don't know exactly how that will work. Let's see. 18 plus... No, I think here what you need to do is get them to the same base, which is possible because log of 9, you just pop it log 3 of power of 2, and power of 2 times 1 divided by 4, that will be 2 divided by 4, which is 1 divided by 2, which is square root. So you have log free of 1 divided by 2. So you can just do the 18 plus 1 divided by 2 on the log, and then you divide it by 2. Okay, so he popped it like that, and the 1 divided by 4, essentially he popped it as 2 to the power minus 2, which makes sense because it's just 4 but it's flipped. And when he gets that power on top, we'll see what we'll have. Plus minus that's right there. So you mean to tell me that the 2 power minus 2 has just disappeared magically? By the looks of it, this is what happened. And why did it disappear magically? Is there an explanation for that? Should be, man. Let me see what explanation is available for this cause. Basically, I understood why. It's because you take the powers, you work with the powers. Minus 2 divided by 2 is going to be minus 1. So you have the 2 at the power minus 1. And you just put a minus up front, so you get this.
Супролидой є
Close sound, because it's not necessary. And based on formula, you divide it like that, so you got 9, so you got 3 power 2, so it's just going to be 2 divided by 2, so it's going to be 1, because log 3 just cancels out. So you have 1 right there. And let's move on from here. I'm going to move on from here. This first exercise is also not what I need right now. This geometry problem, huh? Let's see how it is. Got this triangle ABC, and A is 60 degrees and C is 45. You just put that on the drawing. And BH has the height of just square root of 3. Find the area of a triangle. Basically, the area of a triangle is, I think, area of base times height divided by 2. Height is BH. Area of base is going to be just AB times BC times AC, right? Or no. Or just AB times BC, stuff like that. So we gotta find out what is AB, what is BC, and what is BH. So you have 60 right there, 45, so B, what's that? In total, you have, based on the degrees, 105, so that one must be 75. So that's, it's 180 in total. Yes, that should be correct. And, yes, that's 75. And the triangle, that is in the triangle ABC. But if I take a look at the triangle ABH, basically H right there is 90 degrees, so the B is 30 degrees, so we can work with 30 degrees to understand what is the other one. So we do Pythagorean and we'll understand what is AB, and then we'll do kind of the same stuff with our triangle. Right there is going to be 45 and 45, so work from there. It's going to be like HC is equal to BH, so work with that. And we're basically going to find out what it is. Just go to free right there. That's formula, which you just said. AC. Actually, bottom line, we gotta understand what the bottom line is, huh? Yeah, just go back to formula. AC is square root of 3, so we gotta understand what is AC, huh? The line at the bottom. Well, for this, we need to understand what is AH and HC, so pretty much we plus them out and we got AC. And that is done with a 30 degree stuff and Pythagorean theorem and stuff. So we got ABH 30 degrees. So what that means is that AH is going to be just square root of 3, right? Because it's AB divided by 2, so actually not, because it's going to be the bloody that of hypotenuse is divided by 2, so that's going to be x. So just pop Pythagorean theorem right there. 2x right there. So you have ab to the second power equal to h to the second power plus bh to the second power. 2x second power plus x to the second power plus that to the second power. You have 4x to the second power equal with x to the second power, and that is 12. So you have 3x to the second power equal to 12. X second power is going to be equal to 4, so x is 2. We know that x is 2, so we do know what AH is, and AB we know it's 4. Perhaps this guy is just going to take this approach. He's going to do the Pythagorean theorem in ABC, although I don't know if that is possible. Yeah, I think not. So now we gotta understand what is HC. In triangle BHC, well, we got 245 degrees, so from my assumption, BH is equal with HC. So we got that, and we have 2 square root of 3 right there. So AC is gonna be 2 plus 2 square root of 3, and multiply that with square root of 3. So we have to multiply every term, so we have 2 square root of 3 plus right there 6 centimeters squared because it's area. So that is what we write down the response. Pop the parentheses to denote that this is the whole range of stuff that is under the centimeters. This one of sign, I guess, so circles. So yeah, I'm skip this one, mate. Cos and stuff. I don't even know stuff with a cos. Skip this for mates. Skip this for mates. Let's see, probability. Probability. This one's new. Like this type of exercise. So you have 2 bins, and one has 4 white balls. The other one has 5 black balls. From the first bin, 3 balls are randomly taken, and they are placed in the second bin. Find probability that in the second bin white balls will be more than black balls, or equal to them. Fucking twisted problem. I guess I can pop it. So he has popped this like schematic thing. 2 bins. Bro, this is gonna burn my brain. You have 4 white balls in the first bin and 5 black balls in the second bin. Why he has written it like that? The same thing in the 2 bins. 3 balls are taken. So we gotta have more white balls and black balls are equal in the second bin. I don't know why it's raining like that. I gotta check it out. Let me see right now. Okay, so I think the people that got this condition are morons, because I thought in the first one there are 4 white balls and in the second one there are 5 black balls, but actually they contain the same amount of balls. So they both have 4 white balls and 5 black balls. So this is basically the condition, and goddamn it, I gotta pause a bit. 1 second. Done that. Like I was saying, we got this, and let's see the schematics. Alright, so schematics like we had before. So, what's his range here? 42 or what? Why 42? Goddamn handwriting. It's on a PC, it's not even with a tool, just with a mouse. Okay, so like I said, that, and 3 balls are taken into the second one. So anyways, how do we calculate total number of cases first? To calculate the total number of cases, what do we do? Basically, how do you do this, man? First time I see this kind of crap. C 9 3 Y 9 because in total there are 9 balls and 3 are moved. That's kind of a logic, stupid logic, whatever. These are the possibilities. If you move 3 balls, essentially you have 4 white balls and 5 black balls. So in order to have an equal or bigger amount of white balls in the second container when you move 3 balls, you gotta have at least 1A. So these are all the combinations. Why did he wrote down that 3 black balls can be moved? This cannot be happening. Should delete that. Oh, so he deleted that. Okay, so when you move 1 white ball, it's gonna be 5 white balls, and 7 black balls. So yeah, these are the only two cases where this is not an issue. So you got this. And how you pop the A. Basically you're gonna have, once you move 7 white balls. Yes, 7 white balls. And what do we do here? We get the combinations. In total there will be 12 balls. So out of 12 balls you take 7 white balls. And that is 3 times for the first row. And of the second one is gonna be, you have 6 white balls and 6 black balls, so you have 6 out of 12, 6 on top times 2 plus, or no, times, basically the same stuff. So it's times 3. And get that and solve it. I doubt that I'm wrong. I am wrong. Looks like. He just did an upper approach. What the fuck are his problems, man? He didn't take into account when he will move balls. He just took 4 white balls that were initially in the bin. And he put 3 right there on top because they're free. And the second one did the same thing. That's basically that. Alright, so calculating this, we have 7, 8, 9 below 2 times 3. Pop to the 1 because they're morons. Why do pop the 1? Doesn't make a difference. You have 7 times 3 times 4, and that is 1. How much is that? 84? Yes. And that is van. Now we calculate the m, which will be obviously smaller. So calculating that's going to be 4. That's going to be 6. That is going to be 5, right? So m is going to be, that's 4 plus 30, so that's 34, so is that. Simplification, and we have 17 divided by 42. So that is not, I mean, you write down in your, when you do the test, write this down in your sheet where you do all these calculations, and in the final exam sheet you just write this down, whatever. Who cares about that? No one watches this for that. No one watches the streams. Let me see. This one I skip, right? And yeah, I guess I'm gonna have to find another video because this stuff I don't care about. Well, this one should be alright. I'm gonna take this lesson. I guess we have like 10 videos left to watch, or maybe more. I watched like 30 videos so far, I guess. Obviously the parts that I actually wanted, I watched like half of the time frame of videos. So work with this. So basically we have a 2x2 determinant dx. Basically find this, solve this in equation. Basically, this dx smaller than 5. This integration shit is pretty hard, but we're gonna give it a shot, you know what I'm saying. The first part is actually pretty easy, I think. You just multiply diagonally and minus the second part diagonally, so it's gonna be 2 all the times square root of x minus 1 parentheses, and then minus 3 times that in parentheses, that's on the left, bottom left. Basically solve that. Fuck knows what dVA will be. Just watch this, it's gonna get that minus 3 plus that, because there are 2 minuses, and so I have minus 5 right there, and that is that, smaller than 5. Okay, once I got that, how do I solve? Move that to the right, so it's gonna be 10. Just divide that, it's gonna be 2. So you just pop everything to second power, so it's gonna be x smaller than 4, right? And it can also be x what? Smaller or equal to 0. Guess based on the dVA function of square root, and then you just place this on the graph. You have this, and so the common value will be that, and you place the parentheses correctly, whatever. Next up with this imaginary numbers, like I can pop this, no issue. Like looking here should be like a quadratic stuff, quadratic. So you just do multiplication. You should be getting the quadratic, we'll see. So we got 3 terms for a quadratic, to solve a quadratic. Pop the second power, and you multiply it like that, like this. You will have the formula right there. And you do know that out of second power is minus 1, so you're going to place that. So you place that, and you will have essentially the simplified, and you will have basically minus 9. Yeah, minus 9. And usually when you solve with delta and regular stuff, if it's minus, you just fuck off. But here, you just place, instead of a minus, out of second power. So that's going to be our delta, imaginary stuff. And now we solve x1. And basically, square root of that is going to be 3i. Minus b is going to be that. So basically, that's formula. That stuff is relative minus, so you just pop it like that. So minus 3i. And what you have exactly this, and you place everything divided by 2, so you will have 1 minus 2i right there. And the second stuff, it will be 1 plus I. It's not going to be 1 plus 2i. This is what happens here. And yeah, in the solution you will write down z1, z2, and don't have to say z1 equal to that. You just write it down like this, it should be fine. Now exercise 4, right? Okay, so this one, like working with the powers and so on. 27, I'd place it as 3 at, or 3 at the power of 3. And so if the power goes to the right, it's going to be 3 at the power of 6 divided by 3, which is 2, so we have 9 right there. And plus that, but minus means we flip that, so it's going to be 4 at power 2 16, so it's going to be a 9 plus 16 right there, 25, so square root of that is gonna be 5. Like, this one's pretty easy, bro. Like, any like that. So essentially, it's being shown what I just said. Next one, nigga. LOGA2. Well, the 8, we can write it down as 2 power 3, the base. And we have 2 power of 1, like that number. So it's going to be 1 divided by 3 at the beginning, and there we have LOG22, that's going to simplify, so should be just 1 divided by 3, right? Let's see. Yes, bruv, it's bad. I didn't even need to look at a formula sheet, I just know this stuff. Limit right there. Don't care about that. Yeah, just shown multiple iterations of how this might be solved. Just skip this through. We have this geometry problem right here. This triangle ABC. It is 90 degree in A. And BK divides AC. And BK is like that kind of line that splits B in 2 exactly the same angles. So ABK is going to be the same as KBC in terms of angles. That is also displayed in the drawing. AK is 8, KC is 10. Goddamn, with circle. I'll skip that, mate. I told you, I don't like this circle stuff. Yeah, gonna be back a bit later, like 2 minutes stuff. Here it is. Here it is. This exercise. We pretty much already did this type of stuff, of course. But this one's a bit different. So we have this X mattress. So you gotta understand if it's inversible. Inversible means that it's not equal to 0, because if it's not inversible, it's equal to 0. So you just basically solve this, find X by saying it's not equal to 0, stuff like that. So you just know how it is, multiply diagonally, minus, and so on, and work from there. Yeah, work from there. That is that. You have minus 15 right there, plus 42, plus 4x equal F1. So you'll have well, I guess he moved on. Anyway, so you have x1 is 2 plus 1, then x2, I don't know exactly what's that. X2 plus px plus q is equal to 0. Okay, so I understand that. Do we have exercise like this? Like, come on, let's move on to this. Solve this. 32 at the power of minus 0.6. Well, you just write that down, the power as minus 6 divided by 10 is the same thing, and the 32 write down as 2 to the power 5, and so it's going to be 5 times minus 6 divided by 10 that you solve, and you work from there. Okay, so you can actually multiply by this decimal, and you will have minus 3 to the power minus 3. So much is that? That is 1 divided by 8. But should I write down 1 divided by 8? Anyway, you have minus 3 right there. And what do you do with a 5 and 4 minus 5 right there? Well, just do that multiplication, and you have 5 divided by 8 right there. And now 4 minus that, you just do that and get the same stuff. It's going to be 32 minus 5, 27 divided by 8. Now 27 is 3 to the power 3, 8 is 2 to the power 3. So you just remove square root of third stuff, and you'll just get 3 divided by 2. Okay, so that's that. That's done. Go with that. So working from here sounds a bit harder. Fuck it, like this, and move on from this. And bro, that's the whole stream right here. I'm gonna find another stream, another video, Alright, so let's see. Okay, so start up DBA. Just want to skip this stuff. Skip this stuff, man. Don't care about this. Okay, I got this, you got that. Now work for this exercise 6 right here. We have a complex number and z, yeah, for which is that. And a z with a line on top, you know it's a minus bi. And out of second power is -1. I know how to solve this stuff. Should I just skip this stuff anyway? Reinforcing the foundation and so on. You got that, you got this. So you have a right there, plus bi, plus ai, plus bi second power, that. Now instead of second power, just put a minus right there. And now you just work with stuff. Pop it like that, pop like this. And now we can work with that. And we will get this. A plus b. We have that. We have a number there, so work with that. It's going to be b equal with 2 because of the a that moves there, so it gets cancelled out. So a is going to be minus 2b, so that is -4, and it's going to be -4 plus 2i. That is our complex number z, solved right here. And like explanation has been shown here, I guess. Now exercise 4, basically here you have to show that this expression is a perfect square, which means that it's a natural number that you can just square root easily. So like 16, you can square root that, it's gonna be 4, no problem. Okay, so first thing I gotta do is just put a 3 power of 2, and then times that, and work from there. If you just explain the previous exercise here, I don't know who's going to do exercise 4 now. Yeah, actually it does the exercise 4 right now. So it's gonna multiply like that, huh? Okay, so he decided to do like this, split like that. I guess that is a possibility. Don't have an issue with that. So now we just do with a 2 power 3, right? 3 power 2, and so we got that. And now it's just gonna pop the 2 right there in front of log3. You're gonna pop it to the power of 2, so it's gonna be 36, because it's gonna be 9 times 4. You're just gonna simplify that, and you'll have 36, and that is indeed a perfect square. as shown here, and we'll go to the next exercise now. I guess now another approach is being encompassed. So you could work like this, and then you would have this and that and this. Sounds harder. Fuck this thing. So yeah, I'll go from here. Let's see, geometry stuff, huh? Like the easier geometry stuff. Still has a circle, so yeah. I wouldn't say it's that easy, bruv. We're from here. Okay, we got a circle right here. Pythagorean theorem and so on. And what do we have? Again, some complicated stuff with pi. I'm gonna skip this geometry stuff. Skip this. I already saw stuff like that, so I'm just gonna skip that. Sine, and so on, skip this. Yeah, we'll just find another video now. We'll be back. Most of his life is just paused, but whatever. Full screen. Alright. So, it's gonna start off with 5. Of course with 5. I mean, this one I guess I can pop, although the DVA is questionable. Right. So, pre divided by 2 power 2 times that, right? And that is power of 1. We now have the same exponent, so we can just work with that, equaling the exponents. But we do have the smaller or equal sign right there, and so we work with that. We have 3 right there, and we switch the sign and the symbol right there, and so we have received this solution. Proceeding with the next exercise, we have a z right here, and we have to understand the module of this z number right here. And how is that completed? Well, essentially there's a formula that is square root, and in that square root is a to the second power plus b to the second power. And to do this, you just do that. A is 2. First we have to take the parenthesis out, and we'll work with that. B is basically the part with I. So yeah, I knew this formula. It's not the first time I see such exercises. This one of course is slightly different. So first we expand that to the second power of expression based on the formula, and we will receive 2 minus 12i plus 18i to the second power. But the I to the second power is minus 1, so we just switch the sign. And so we have minus 16 minus 12i, and a is going to be minus 16, so pop that to the second power. It's going to be a positive number, and that is going to be 256, and minus actually plus 144, and that's going to be 400, and the square root of that is 20. So we have received our module right there. And I guess another solution is being displayed currently. We have this solution, and basically this is the formula that has been used, it's just being expanded. This is how it is applied. Okay. Next exercise. Skip this. Geometry. This one should be a bit hard, as there is 6 points instead of the usual 5. We got the BM, which is the middle. So basically it splits the AC in 2. That is 5. AB 6. We gotta understand the area of this triangle, which should be the height of this triangle times AC divided by 2, stuff like that. So yeah, this one's pretty hard. I might just skip it as well. A times B, so actually it's AB times BC. Well, okay. So by the looks of it, it's not that complicated. AC will be 10. Thanks to some formula. And then we will apply Pythagorean theorem. And we will get 8 right there. Alright, so that will be 24, right? Centimeters squared, as it is the area right here. So this one's harder, I might just skip through. And parameters being solved a bit. Yeah, I'll just find another one right now. The pause should be not that long. This is the one I found. Alright. You just gotta find this alpha. So that z is purely imaginary, so we know that this means the real part will be equal to 0. So we have to work from there. Alright. So a is equal to 0, like I have previously remarked. And now working with bi. So bi is that. Now we just multiply basically like that diagonally. We know that I to the second power is -1, so we'll work with that. Okay, so we will have bi plus I to bi second power, and that is bi minus b, and that's that. Okay, now we just have to work with the real and imaginary part. bi is going to be equal to 3i, so b is going to be 3, and minus b is equal with that. So now we will understand that alpha is indeed what? 1? Should be 1. Actually -1, yeah. So -1, that is the alpha, and z is that. Another way has been shown. Whatever, I'll just work from here. We have this exercise right here. So how do we solve this exercise right here? Well, I can essentially work with that. You're like at the top, you know, is gonna be log of 2, 3 divided by 18, stuff like that in it, based on the formulas and so on. 3 plus 6 is minus 3 plus 6 is that. So basically he just switched this around. That is a possibility. And so we will have now log2 of 6 right there. And now just put to a second power. And so we will have 36 right there, because the 2 moves on to the power, and the 2 with the power of log2 just cancels out, and so it's going to be 36, and the square root of that is going to be 6. That's a guess based on the condition to prove that this is a perfect square. Okay, so that's 3 power 4, that's going to be 3, and square root, that's 9 right there, right? Okay, so that's that. And now we work with this one, kind of similar one, dva. Work with what, log not equal to 0. So x is going to be that based on the power, not equal to 1. Okay, not equal to 1 then. X bigger than 0. And now move on from here. Got dVA right here. Divided like that, -1. So if we multiply like that, we'll get this. And we can work from here. X is going to be 2 power 2, so X is going to be 4. Sounds pretty complicated. I want to say that this is like a easy example right here. So I'm just going to kind of skip through. We got this line right here and whatever. We got this. Okay, so you just do this determinant, you multiply diagonally minus that. It's going to be that, so it's going to be just plus 16 right there. Okay, so that's right there is just a formula. Z minus 2i all to the second power, because it's twice like that. Anyways, you can multiply term by term and you're going to get the same result. Remember that I to the second power is -1, so you just flip the sign and so on. So you will have this right here. And you get this canonical form. Now you just do the delta. Okay, so delta b to the second power, which is going to be that to the second power minus 4ac, you get that. Okay, now 16 out of second power. And my stream is smooth, you can see by the camera of recording here of writing on the screen is not that smooth, but that's not an issue because just text right here. Can understand everything is high quality. That's what matters. And the delta we will have minus what, 64, huh? 64. So now we just do the square root of that, which will be 8 times I to the second power, just to make the actually 8i because it's already square rooted. So you have that 8i. I to the second power will just provide the minus, and square root of 64, that's just 8. So now we just apply the formula for I minus 8i divided by 2. 4i is a b with a minus, it's going to be that. So we will receive that right here, minus 2i, and now this right here is going to be 6i. So this is our result. Yeah. Plus 16 right here. This is, I guess, another way to solve this by notating the stuff that you're about to put a second power with t. So you get something like that, and you get something like this. And then you would replace this. Yeah, maybe this was easier, but I just picked the normal option. Okay, now we have this exercise right here. Right here, man. We can see that the base 5 is being repeated. So it would be nice if we can work with this base 5. It'll be just 1 divided by 3 times 15, so that'll be log55, which is nothing, and I'm not sure if it's 1 or 0, perhaps 0, and that stuff right there, 3 square root of 27, you just do it quite simply. 27, you put it like 3 square root of 3, and you will have just 3 right there. So perhaps you get that. So you get this. So it's actually 1, it's not 0. So you get minus 2 like that. So 2 power minus 1, 2 power 2. So it's going to be up front 2 divided by minus 1, which is minus 2. So this is minus 2 right here. This is what it is. And now 3 equals with 2 at what power? log2 3, right? Yeah. Because 2 with log2 power cancels out as 1. So it's going to be 1 times 3. That's going to be 3. Okay, now this is like another example right here. 0 like that, dVA, based on the fact that it's the square root on the denominator, I think it's called. I'm not really that sure. So x can be bigger than 1. Now the second thing, we work with that. So it's going to be that, and we just multiply diagonally, put everything to the second power, so it's going to be the same thing but without square root. And we will have minus x plus 2 equals 0. So x is going to be 2, put that on the fucking line, and put the 2 and the 1 on the line. We gotta put everything from 1 all the way to plus infinite, and then from the 2 just gonna be like that there. Actually here's with plus and minus, right? Where is it? Whatever, I don't know what this guy's doing. Plus minus, huh? Plus right there from 1. Cause if we place that in the function, we get that. So plus right there, and minus right there. Anyway, we get this because we need the negative values. Yeah, I'm gonna get my be right back screen.